Hey, hey!
So what we're doing tonight is we're taking our shell scripting and we're going to put it on the cloud. We're going to scale it up to infinity. We're going to go on a roaring rampage of not revenge here, but of scripting. So we are going to roar, we are going to rampage, and we are going to edit some videos in a cloud solution which scales infinitely automatically. All right, so a little bit about me. I've got a React Pro course coming up September 15. I'm the lead instructor at a code school now. Everything else, woo! The most important thing here is I am the Dr. Mario World Champion. Literally, I've never lost. Try me. So let's go over some terminology. Who uses Amazon on the cloud? Word. And who uses Lambda every day? Who uses it to, like, Wallace and Gromit put his pants on with Lambda? Okay, just me. So we're going to see a few things from Amazon in this talk. API Gateway, who uses? Everyone. Everyone uses API Gateway. So we're going to see how to use a Lambda to do our authorization in API Gateway. The Lambda is going to decide 401 or 200 or 403 if you're like that. Everyone uses S3. Everyone remembers when S3 went down for like 10 minutes and the world stopped turning. Yeah, it was a rough morning. We were checking websites to see if they were down. All right, so we're going to do something extra in S3 today. We are going to trigger our Lambda from S3. Someone uploads a file to S3. It will automatically trigger a Lambda, and that will let us run our code without a server. Our big goal today is running without a server. So obviously Lambda, everybody uses ffmpeg. ffmpeg is the king. We're going to use that. That is our command line program that we are going to use to edit videos. We're going to cut them apart. We're going to take frames out of it. We're going to put them back together. Obviously create React app, but I asked you guys last time if you know create React app. So this is what we're building. We're logging in. The password is definitely not Archer's password. So we load all of our little film strips. We're going to upload another video, and we're going to wait. I should have sped this GIF up. We can edit the order of these videos, and then our video will load. Give it like 3, 2, 1. There it is. I got that right on video too. So then we are going to, I'm not going to ruin the end of it, we're going to combine the videos together into a mashup, and what we're going to see as the demo at the end is a mashup of all the kills in Kill Bill, one after the other. Bam, bam, bam. Super violence. All right. So, hyper violence. I don't know, you've all seen the movie. So we're going to use ffmpeg. We are going to put everything on the cloud. Scale infinitely, that's the marketing term. We are going to secure our assets. We are going to upload our videos securely, because who knows what's in these videos. We don't want them leaking. And we are going to deploy even our front end with Lambda. Even our front end. Nothing gets by Lambda. Lambda does everything. So this is a diagram I made of our entire build. We're starting over, I don't know if you can see my mouse, over here on the right side with the ffmpeg. Our goal today is to make all of these APIs, and we're going to start by running ffmpeg on a video and getting those still frames out so we can show the film slides on the front end. So here's a little bit about ffmpeg. You guys all know that because this is like the highest level audience I've ever had. So this is the command. I'm sure there's at least 2 people in the audience who could tell me that. They'd be like, FPS is frames per second. We're ready to go. We're going to get some stills. And we get to see a little architecture diagram here of what we're doing. We have a node process. It runs a spawn, which is a child process, and that will run a command as if it's the command line. So here, yada, yada, yada. But in reality, we're going to run our VF with an FPS of 1, which is going to create ping files of slices of our frames from our video. So that's the actual code that I wrote in my actual text editor. I think we went 4 for 4 today with light theme backgrounds in the text editor. So, woo! The first Emacs, it's the last Emacs too. And it's GNU, please. So here's our first kill. Here's the bride taking out Vernita Green. And this is how I felt after getting every task done in this entire build. So I had to put the slide in. So we got our first kill. We got the stills coming out of ffmpeg on the command line. So next, let's go to the console in Amazon, and let's do our S3 trigger. So we have an S3 bucket. We want to trigger our Lambda, which calls ffmpeg. Now, ffmpeg is a program. It's a binary file, so we have to put it in a layer. We don't have to, but it's the best thing. It's a new feature in Lambda, or newer, where we can take binary files that are programs, we can put them in a layer, and we can use them in any lambdas we want. So for this project, we won't see it, but I made another layer even for sed. So yeah, woo, sed and Emacs, things from the 70s. So here's what we're going to see now. We get the Lambda. Obviously, Lambda is the sharpest steel in Okinawa. So we're going to use it to destroy everything. And by destroy, I mean make, because here we build things. So a little bit about Lambda. For those of you who haven't used it at work, it is great. It does everything. You can trigger it from a queue. You can trigger it from an EC2, from a machine learning something. You can get an email and it trigger a Lambda. And obviously S3 triggers and API gateway triggering Lambdas. It's called a proxy integration. They scale infinitely automatically. Your code stays 50, 60 lines at a time, which is great because everybody remembers that first project they did in high school and it was like 14,000 lines long, and we don't talk about it anymore. So not that anymore, 50 lines of code at a time, and we bill by the millisecond. So the bad things about it are the milliseconds are expensive, so we try not to use too many of them, and the first three items here are basically, it's complicated. Debugging problems, it took me hours for certain bugs that I got. You get a 403, then you get a different 403, then you get a different 403, and it turns out this thing had the wrong resource marker on it. Sometimes it's a mystery why something doesn't work, and you got to solve it, and it's tough. So it's not for the faint of heart. I think Benji was talking about the struggle. Yeah. The struggle is real. All right, here is our full architecture diagram for our S3 upload. This is very common. I've done this at a couple of different jobs. We have one S3 bucket. That's where our files go. Somebody's going to upload there. It triggers the Lambda. We get the object from the Lambda. That's how in the Amazon SDK we say download the file. We run ffmpeg on that file, on the local file system that Lambda pretends to have. Then we put object. That's how S3 in the AWS SDK says save the file back into an S3 bucket somewhere. And we have to put it in a different bucket or make something different about it. For instance, the trigger we can say only runs on MP4 files, or it has a certain prefix. But obviously, if you put the file back into the same bucket, it's pretty easy to make an infinite loop. That guy gets it. He's doing this. Either that or I've run out of time. Already? So I want to go through, this is JSIL. I want to go through a little bit of JavaScript. Some of this JavaScript is a little bit ugly, but it's real JavaScript. It's every line of code you see here is the actual line of code that I have in production, except for a few places where I've like commented out some configuration. So here, exports.handler is how we say in like the old Node CommonJS pattern, this is what we want to export. It's called a handler. It's a function. We're only ever going to use the event in the context. Event is where Amazon is going to tell us everything about what triggered this Lambda. It might be an API gateway HTTP call. It might be an S3 upload. It might be somebody texted your mom. Anything could happen. It would be in the event. You can check for it. Context is more like the response object from Express, where it is going to give us a series of functions we can use to succeed or send data back, anything we want, just to say that the Lambda failed, even if we don't care. It'll end up in our CloudWatch logs, which themselves can trigger Lambdas. So here, we're reading data out of the event. It's nothing too special. I think I copied most of this off of the Amazon tutorials. This is the same Lambda. This is our Lambda, which is downloading the video file and making the still images. So the second thing we're going to do after we've read the data out of the event is we are going to s3.getObject. Now, I like wrapping things in old school promises. You got some async await with Gil. You got a discussion of async await. Benji loves everything. So I love the old school promise API that looks like this. I once implemented it in a job interview and I got that job. So I show some loyalty to it. S3.getObject is going to load the object, that's how they call files, from the S3 bucket that it was uploaded to. And fs.writeFile, fs's file system, is going to write that file to our, what we think is our local file system on Lambda. So the next step is we are going to spawn the child process, which is ffmpeg. Basically the same thing. We've wrapped it in a promise. There's a few differences you'll notice from the previous time we saw this code. Here, ffmpeg is a variable. ffmpeg is in a different place on my local runtime as it is on the Lambda runtime. In Lambda, it's inside the OPT directory on the root file system because it's from a layer. On my local file system, it's in the path, so it's just called ffmpeg. And also, we have a different temp directory, excuse me. So locally, I can say a relative path for the temp directory. On Lambda, again, you don't really have a file system, so there's certain things that are a little bit wonky, and you have to use fully qualified paths. And one thing here is the temp directory. You have to kind of pretend that you're at the root of the file system. So I load it from config and put it in a variable, and it all feels the same at the end of the day. And isn't that what matters? So we run the process, and we either resolve or reject the promise. Then we've created, after ffmpeg runs successfully, we've created our still images. So now we fs.readdir, we read the directory to get all of the image file names out. And our goal is now we're going to upload each of these to another S3 bucket. So if anyone wants to explain why I use the squiggle operator.
You don't like includes, and you like bitwise operators.
I like a bitwise operator on my .index of. That's exactly right. That's just a shortcut for checking if something's -1. So if you learned anything today.
Don't learn that.
Don't learn that? How to write code that people who take over for you at a job don't understand. And yeah, but it's after you leave the company. It's like that, darn, we should have kept that guy and paid him more money. So now that we got the files to upload, it's an array of strings. We are going to map over them. You see this is inside promise.all. We got 2 promise.alls today, which is awesome. So we're going to do all these uploads in parallel. For each file name, we have a promise which reads the file off the file system and put object, that's how to save the file, up to another bucket. Here, some of these variables I've loaded out of the config. There's nothing above like a grade 11 level of JavaScript in here. If you're a 17-year-old Israeli high school student, you should be able to write this code. So hooray for everybody. And that's all there is to it. That you just saw all the code that is a global scale video editing Lambda. So just to review, we upload, it triggers the Lambda downloads the file, the Lambda spawns an ffmpeg, and it uploads the new files to S3. And I made that in MS Paint, so hashtag old school. So the S3 triggers, I put a slide in here in case you're interested in doing the tutorial from Amazon. There's a few wrinkles in there, but mostly it is what you think it is. You want a file, and when that file comes in, you get new files out. So here's the output files for when I uploaded the Oren Ishii death scene. It's actual screenshot from S3. Here's the actual stills. So we've gotten our second kill, and the Hattori Hanzo blade, Lambda itself, has proven effective in solving our problems. So we cross our second build list off. I'm going to start moving a little quicker through the next couple sections. We're going to do security. So how we're going to do security is with API Gateway and with the Lambda Authorizer. Some of the code for the Lambda Authorizer is a bit longer, but it's simpler. We're checking if the password hash works, and we're making a token. So one thing that I wanted to do in this build is I wanted to secure all of the images end to end. And the only way to do that I could find was by putting the token in a cookie. And that way, on the requests that bring the images from the server, we have a cookie there, and we can secure those image and video requests. So obviously, if your videos are private, your videos are private. You know what I'm talking about. So this is the part of the build we're doing right now. We have a login route, and we use the Lambda Authorizer, highlighted, as part of our API Gateway to secure every different API request that we need security on. So login, load list, that's going to load our list of videos, load images, and sign upload. We're going to see in the next section what signing and upload means. I'll give you a hint. We're going to make a signature, and then we're going to do an upload. So a little bit about API Gateway. It's anyone who's programmed in Express. Almost everything you do in Express with the app object is what we do in API Gateway. So we define routes based on their HTTP verb. We define a path. And we might set a couple middlewares here. The Lambda Authorizer is what we would use a middleware like Passport back in Express. So the thing about the permission scheme that I did want to say here is Lambda can do anything. You can literally write a Lambda that sends you a text message and waits for you to respond. And as long as you do it fast enough, then you can use a text message based authentication system for your web app. Like, you can really do anything. Anything. So here's our flow. We make an HTTP request. It goes to API Gateway. API Gateway goes to the Lambda authorizer, which can either say deny, which goes right back. It actually goes through API Gateway and sends the 403 correctly. Or it can say allow, and that will carry on the request to whatever API Gateway is pointed at. In this case, a Lambda proxy integration, which is a fancy way of saying API Gateway calls a Lambda the same way Express was going to call your route handler. So this is the login. It's a little bit of code. The first section is just hashing passwords. The important part here is after if password hash equals expected hash. That means that we've logged in correctly. We say JSON web token.sign, so we're making a token and we're sending it. We're making this response object and setting a header of set cookie. So we're setting a cookie with the token in it. Okay, so this line of code, context.done, is a very node-looking API. You pass in the error first and then the data second. So that response object is the response that's going to go back from the API gateway to our HTTP request to make a login. All right. So this is our Lambda authorizer. This guy is doing all the work. Again, it's a little bit of dirty code here, reading out of the event. It's never super clean. I'm using a really fancy regex. I wrote it myself. I'm super proud. Somebody call my mom. I didn't copy paste it off Stack Overflow to read the token out of the cookie. And here we're doing the same thing we would do in Express, jwt.verify this token. The difference is here, when it fails, we generate a policy for deny. And when it succeeds, we're generating a policy for allow. And here we're actually using the callback. I just wanted to kind of show you all the different ways of using Lambda. So they don't have to be fat arrows. This one's a function. The white space is wrong before the word function, so you're allowed to do that. And we're using the callback the same way we're using context.done. Generate policy is a function that I copy pasted out of the Amazon docs, which we're going to see a JSON policy later. Who loves Amazon IAM policies? One guy who is sarcastic. So they're not super simple. This actually, where you see the comment 2/3 of the way through, that resource comment actually cost me 3 hours of bug fixing. It turns out Lambda authorizers, their responses are cached. And when you have different resources on different policies, they'll work for some things and not for others. So it took me 3 hours. I found the Stack Overflow, and then I sent an angry email to Jeff Bezos, which, to his credit, he had somebody respond back to me very quickly about. And they didn't care how angry I sounded in that email, which I did. So I solved the problem. Here, the authorized policies count for any resource, which the problem was there's two different API calls, and it was breaking when you made one and then the other, or the other then the first. So here's our file loader Lambda. Say that 5 times fast when you're doing a talk that's based on a Japanese sword. So here, instead of loading the files directly out of S3, as you might do when they're public, here we're going to use a Lambda to s3.getObject, and that way that Lambda sits behind the API gateway, which has a Lambda authorizer on it. And that way we can load all of our files, videos and images, through a Lambda, through an authorizer. Everything is secure, everything is safe, everything is global scale. So, what's the password? Anyone want to guess?
Lambda.
1, 2, 3, 4.
Okay, you're all wrong. None of you watch Archer. So we've got it working, and we get to see Bud die. Obviously, we don't kill Bud ourselves. But he dies on the floor in much pain from the Black Mamba snake, which apparently is the Lambda authorizer. So we've got our third thing done. We want to move ahead to our signed upload. So I want to move through this a little more quickly. Basically, we could do the same thing we did just a second ago, loading the images through a Lambda, uploading the files to S3. That would use a lot of Lambda. Lambdas are expensive per millisecond. So instead of loading these large video files through a Lambda, what we can do is we can use what's called the S3 signed, what is a pre-signed URL What it does is it lets us get all of the permissions for uploading a file as if we were doing it through the Lambda, but then directly upload to the S3 bucket. So these are great. I've used them on every Lambda project I've ever used files for. Here's our architecture diagram. We make a post request to our signer. It authorizes. It calls a Lambda that has permission to write to S3, sends back a pre-signed URL, and then we make a put request to that pre-signed URL, and that gets us our file to our bucket. So this is the entire Lambda. One thing I really want to get through tonight, there's a lot of people who say, oh, I thought about using Lambda. Oh, maybe we were going to use it at work, but we weren't sure if it was going to do what we need. This is all there is to this Lambda. All there is to securely uploading videos on a global scale is 20 lines of code. I skipped the config. We just load a JSON file. There's one trick in here, which is that in our s3.getSignedURL function, we have to tell it the content type is multi-part form data because that's how we're going to upload it. You might think it's video MP4 if you're uploading videos, but it's multi-part. Gesundheit. I told you I'd speak Yiddish. So this is our policy. This is what allows our Lambda to write things to the S3, which is what allows him to make URLs that allow somebody else to write things to S3. So a lot of times people miss this. There's two permissions you need, one resource for the bucket and one resource listing for everything inside the bucket. So I've seen that one cost people 3-4 hours in business. So we got our fourth kill. We have our upload file. And this is the most satisfying one. I promise later we get to see her squish the eyeball. I promise 100%. So the last thing we're going to do, we're going to deploy our front end with a Lambda. Everything is Lambda, 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 Lambda. How this is going to work is we are going to run a build. And if anyone ever told you never, never, never commit your build files to Git, I actually committed my build files, my build artifacts to Git in this instance. I was using Git to make a zip file. I needed a zip to upload to Lambda, and the Lambda needed the files so that it could respond as a static server with them. So forgive me, I committed my build output to Git, but only on a branch, not in GitHub. I didn't push it. So this is the last thing we're going to do. In API Gateway, we make what's called a proxy plus integration to Lambda, which is kind of a catch-all. If you've ever had an express route that was for star, this will take every request that isn't handled somewhere else in your API, and it will send it to a given Lambda. So this one, obviously, we don't put authorization on because we want people to be able to go to the website. So this one's actually new to me. I found it for this talk, but it's just for this purpose. It's just so that you can use a Lambda to basically solve everything. If you need a 404 page, anything like this. This is the entire Lambda. I feel bad, the code is a little bit wet, like why everything twice? But we needed to base 64 encode the favicon, and I will not admit how long it took me to get my favicon working. So we're going to do our demo. Uma Thurman is about to do the 5-point palm exploding heart technique. She's ready for it, and let's go do our demo. So our demo is 12 seconds long. I hope we have time for that. So this is the website. We load it through the Lambda, the proxy plus integration, the request here for index.html. What's the password? I'll type it in. And we make a login request that gets us our token. And now we can make a request for the list of all the videos. That one was authorized using the cookie. All of these images load using the cookie. So now I'm going to upload a file. The file is PyMay. So everybody knows PyMay is the leader of the White Lotus clan who once massacred 60 devs for not recording their screen. So once it uploads, it's going to take a few seconds here. Not great UX. There's no waiting GIF. It will show up in our list. And P comes after O, so it'll show up after the O-Ren E-Shi-E. And depending on the speed of the internet, I might have to do a refresh. I didn't spend much time on the front end on this application.
Story of my life.
Oh, did I not press upload? I need to press upload. There you go. See, it has a progress bar in the console. So now this is when you would have your progressing.
I'll suggest it to my UX person at work.
Yeah? If you want to see how long your download is taking, just open the console. So now we see PyMay. So let's put everything in order. I certainly want the killing of Bill to go last. So I'm going to put them in the correct order. And let's put PyMay at the end, because PyMay is awesome. So we're going to hit combine. That's going to go to one last Lambda, and hopefully it's not too loud. The video loads through the Lambda authorizer, and we can open it up, and we can see some hyperviolence. Woo! Now, there is an encoding issue with MP4. In a real production build, you would decode out of MP4 when the file is uploaded into something, probably AVI, that doesn't have issues with compression. So you see the audio and the video. The audio always starts half a second before the video switches which scene it is, but they're synced. So there's more features. If someone wants some funding for this, or if someone can get some funding, we can make YouTube editor mode. It will take 6 months and 4.5 million shekels. Yeah! That's the best one. And of course, the 5-point palm exploding heart technique. Bam! And we get to enjoy for 18 seconds Bill walking away. He gets to take 5 paces, and then his heart will explode in his chest. Obviously, it was a Lambda that did it. And afterwards, we get the best one, which is PyMay stroking the beard. And then showing you that you should not fear Lambda. Lambda should fear you. So here, PyMay will tell you, okay, we did everything. PyMay will tell you that all of the code in the entire build is available on my GitHub, github.com/nikfrank/lambdafilmtalk. That is, they're very rough notes, but every single step that I took, including the sed layer, all the extra things, there's 9 total Lambdas in this build, is all on there. And of course, you will not fear Lambda. You are the master of your lives. You are the leadership this country needs. You're the smartest, nicest people there are. God bless America.